Hello everybody, it's Mr. Ray here with our next lesson in grade 11 University Math. We are working in the trigonometry unit. We just finished creating something called the unit circle that was very helpful in determining quickly the different sine, cos, and tan ratios for all sorts of new angles, multiples of 30 and 45, all the way up to 360 degrees and actually beyond. Today we're going to work on other trig ratios that aren't in the unit circle, and we're also going to be looking at coterminal angles. So the title should probably be reversed here. We're going to spend most of our time looking at these related angles, and then at the end just quickly talk about coterminal angles. Hopefully you remember from a couple lessons ago we talked about angles in standard position. We talked about initial arm, terminal arm, and the reference angle, where the arms and angles are located on the XY grid. So we're going to keep talking about that and hopefully learn some new things that we could use as additional tools for trigonometry. So there's our standard position definition, and coterminal angles, we'll talk quickly about that at the end. These are angles in standard position that have the same terminal arm, but these coterminal angles are located in the same place, but they can have multiple or infinite different angle measurements for the same coterminal, for the same terminal arm. Okay, so the key concepts here, I want to quickly review what we learned in the previous lesson when we did the unit circle. So this still applies. If you remember, we talked about how instead of using opposite, hypotenuse, adjacent sides, we could refer, once we put the angles in standard position on the grid, we could, instead of using a hypotenuse, we'll use the radius. Okay, so hypotenuse is equal to the radius, and the opposite side, that's the y value, and the adjacent side is the x value. So basically these formulas here were derived straight from SOHCAHTOA just by replacing hypotenuse, opposite, and adjacent with these more relevant for the grid parameters. Okay, so sine of any angle is y over r. Y is the y coordinate for that arm. R is the radius of the arm. X is the x coordinate of the arm. So cos theta is x over r, tan theta is y over x. And this, we're actually going to use this a bit more today. Since these triangles that we're using are all right triangles, and you can think of one side being the x side, one side being the y side. I'll draw it here, hopefully it'll make more sense. So if I'm looking at a triangle in standard position here, this would be y, this would be x, this would be r. And today we're going to be working with radiuses that don't have to be 1. The unit circle was a circle with radius equal to 1. So that's going to change today. We could have any value for r. So this is a right triangle, and you can see the relationship between x, y, and r. And that's where this formula comes from. So basically, we know that if we know the x and y values, we can figure out what the radius is. Or we could just use the more general formula, r squared equals x squared plus y squared. So if we know any two of these, just like Pythagorean theorem, if we know any two of these values, we can get the third value using this formula. Okay, and these three statements here, they're all kind of related. For any sine, cos, and tan ratio, For example, if I said there's a sine ratio of 5 over 6 for a given angle. Well, there's actually two angles that will satisfy that, two distinct angles between 0 and 360, and that's true for any of the ratios. So you're going to see if we're not told where this angle might be in terms of which quadrant, there's actually going to be two answers for pretty much all of these equations that they might give us. So we'll talk more about that for sure. And we'll get to that in the lesson. And then the coterminal arms have the same terminal arm but have different angle measurements, which can be positive or negative. Okay, so let's just kind of dive into this. Well, the other thing I want to mention too, these values of r, x, and y, you know, the x and y, those are related to coordinates on the grid. So x and y can be positive or negative. And that's important to know, because before we were thinking, and the triangles, they all had to be positive, but that's not the case anymore. So x and y can actually be positive or negative, and that's going to open this up to have some negative sine and cosine and tan ratios. Okay, but the value for r represents the radius or the hypotenuse. That value can only be positive. If you think of a circle with a radius, you can't have a negative radius. You can't have a zero radius. So this will be important later on. So x and y can be positive or negative. R can only be positive. Okay, so this would be a typical question you might get. They're going to give us a certain trig ratio with a value, and then ask us some information about it, like sketch it, come up with the other ratios associated with that, or figure out what the actual angle is. Okay, so first thing I would do, okay, so they're saying given that sine of angle A is equal to 3/5 and that angle A lies in the first quadrant, determine exact values for the other two ratios for that angle, cosine A and tan A. Okay, notice they told us that it lies in the first quadrant, and that's because what I mentioned earlier, that there's actually two angles that will satisfy this. Okay, and we're going to talk more about that too. So, but that little piece of information will narrow our answer down to one unique value. Whereas if they didn't put that there, there could be two possible answers. Okay, so the first thing I'm going to do is write out the ratio they gave us. Sine A equals 3/5. Well, we know sine, if we go back to here, the sine of an angle is y over r. So if I write y over r right beside that, that actually tells us two of the three values right off the bat. So it tells us that y is equal to 3, and it also tells us that r is equal to 5. Okay, now remember what I said about r. R has to be positive, so I know r is positive, so that well, let me back up for a second. If I knew this sine ratio was 3/5, well, that could mean that the top number is -3 and the bottom number is -5, which cancels out to become 3/5. Now, that's because r can only be positive. That takes away that chance that they're both negative. So in our case now, the fact that they told us sine A equals 3/5, that we know that r is positive 5 and that y is positive 3. Once we get to tan ratios, it's a little bit trickier. So so that's the values we know. So how do we get the third value? We don't know what x is. So this is where basically our Pythagorean theorem comes in here. R squared equals x squared plus y squared. So let's do that. So I just plug in. We know r is 5, x we don't know, and y is 3. So 3 squared. So I get 25 equals x squared plus 9. So x squared is 16. Okay, now when you take the square root of 16, most people just say, oh, that's 4. But it's actually two values. It's plus or minus 4. And we have to consider that because x actually can be positive or negative 4. We know that. We've talked about that before. X and y can be positive or negative. So we'll work with that for now. However, that piece of information they gave us about being in the first quadrant will take away one of these options. So let me just do a quick little sketch here of the XY grid. Okay, now they told us the angle's in the first quadrant, so that means it's somewhere over here. I'll just put Q1 here. So in Q1, what are the values of x? Well, excuse me. We know in Q1 x is always positive because this is sorry about that, I had a little frog in my throat. Okay, so back to here. We know the angle is in this quadrant because they told us that. So you ask yourself, because right now we're not sure about x, the value of x for this ratio. It could, we know it could be positive 4 or negative 4. But if we know it's in quadrant 1, we know in quadrant 1 x is always positive and y is always positive. So that that takes away the choice of negative 4. So I'm just going to write a positive 4 here in there, and we can now write all the values. So just to summarize, we know x is 4, we know y is 3, and we know r is 5. And there's no doubt about signs there. That is absolutely true. Okay, so now I can start creating a little triangle here in my sketch. So I know that, you know, x is 4, so I'm going to go out 4 units here. Okay, I know that y is 3. So basically my triangle the top corner will be where those two meet. And I'll draw my radius, my r, going from the origin to that point. Okay, and I can actually, you know, I could drop that down and we know that's a right triangle. So this is the angle that's inside here is angle A. So that's the angle that we're getting that sine ratio from. Okay, and I can also plug in my radius along there. I know that's 5. That was part of the ratio. We got that right away. We didn't have to calculate anything for that. Okay. Okay, so they want to know the values for cosine A and tan A, so we can get down to that now. So cosine A, we know that value is x over r, and we know x and r is 4 and 5, so 4/5. So cosine A is 4/5, and tan A is y over x, which is 3 over 4. So we basically know all the 3 trig ratios just from that first piece of information. They give us one trig ratio and the quadrant that it lies in, and we can get the other 2. So that's a very important skill to have. Now, what would have happened if, you know, if they didn't tell us it was in first quadrant? So let's pretend we weren't told that. Well, that would bring about the chance that x could be negative 4. If x is negative 4, instead of it going along the positive x-axis, it goes out here to negative 4. Y is still the same, y is 3, so we could actually have an angle out here. So radius is still 4, but that's kind of like the similar. It's like an identical triangle. It's just been reflected over the y-axis. So if they hadn't told us first quadrant, there could be two possible values for A. So it could have been this angle here, where A goes from the positive x-axis to that terminal arm, or it could have been all the way across over to here. Okay, and we're going to look at that in the next question. Now, I know they didn't ask us this, but this is, this is another thing that could be asked at this point. What is the value of angle A? So how do you get that? Well, we're just going back to our trig skills from grade 10. If we know that sine A is 3/5, actually we know all three of these, so we could work with any of these three. We know that angle A is going to be the sine inverse of 3/5. Okay, and if you do that on your calculator, you get 36.9 degrees. And if we did the same thing with these other ratios, we will get the same angle. So example, if we did angle A equals cosine inverse of 4/5, we get that. Or if we did angle A equals tan inverse of 3/4, we'd also get that. Okay, so that's another thing that's going to be asked. So what we learned in this question was how to, given one trig ratio, how to get all three values, x, y, and r. As long as we know which quadrant the angle's in, we can do that. And then, yeah, so get all three trig ratios, determine the angle, draw a sketch. So that's what we've learned here. Okay, so that's part A of the question. So we'll be referring to this answer as well. So part B, try to get both parts in there. Determine the primary trig ratios. Now this is the first time we've seen this word primary, and we'll be learning about why we have to call it that. Primary trig ratios are just the sine, cos, and tan ratios. Okay, so we're actually going to be learning something called secondary trig ratios next lesson. So when you see primary trig ratios, just think sine, cos, and tan. Okay, determine the primary trig ratios for another angle between 0 and 360 degrees that has the same sine value. So what was that sine value? Let's write that out. Sine A equals 3/5. Okay, and we already kind of went through this exercise. We knew from that statement that we knew that y is equal to 3. We knew that r is equal to 5. And then we did that calculation. Let me just move this over a bit. We did the calculation to get what x was, and we came up with two possible values, positive and -4. But we were able to clarify which one it is because they told us first quadrant. And because it was first quadrant, it was +4. So the other angle that could satisfy this information, other than the quadrant it's in, would be an x value of -4. Okay, so we want to come up with the other two ratios. So this ratio still stands because this ratio never uses x. So the fact that I'm changing x from 4 to -4 does not affect that. And that tells you that there are two possible angles for just given one trig ratio. So now we're using the other possible value that satisfies this, and that would be x equals -4. So now when we do our cosine and tan ratios, again, cosine is x over r, and tan is y over x. Notice these both use x, which we've changed. So now the ratio becomes -4/5 for cosine and -3/4 for tan. So those are the new trig ratios for the other angle that satisfies the sine A equals 3/5. Okay, and if we go back to, well, actually we'll do that now. Draw a diagram is the next part. Draw a diagram showing the locations of these two angles. How are these two angles related? So I'll just kind of copy what I did before. So I've got my XY grid. Now the original angle that we worked with in the first quadrant looked like this. So it had a 5, 4, and a 3. And the angle A was here. Okay, and then the other triangle, the other terminal arm will be over here in the second quadrant because we're changing the x value to -4. So go out to here. It's basically reflected. So this measurement is -4. It's a little confusing because you ask yourself, am I talking about a side length here or am I talking about the x coordinate? And really, I should be just talking about the x coordinate. So this would be a -4, this would be a +4, this would be a 3 up here. Okay, because sides can't have negative values. Sorry about that. So we've got our two triangles here. This is the original one, sine A equals 3/5 in the first quadrant. That's what the angle looks like with the x, y, and r values. So if we change the x value to -4, this is where the other terminal arm would be, the other angle. So remember how the angles in standard position work? You always start with the initial arm, which is the positive x-axis, and you rotate counterclockwise until you get to the terminal arm. So this angle here, I don't really want to call it A again because it can't be a given angle can't have two values. We'll call it A prime. Okay, so this is angle A prime that satisfies this condition with the x value being -4 instead of +4. So you can see the relationship between these two angles. These two triangles here are exactly the same. So I could say that inside, this angle inside here, that's going to be the same angle that's over here. So you can see the relationship, and that's what this question is. How are these two angles related? You could see if I know what angle A is, well, angle A is also over here. So if I wanted the second angle, A prime, it's just 180 degrees, which is the straight line here, minus the value that A was. Okay. So the two, so I'll show you that with the calculation here. We know that angle A prime is equal to 180 degrees minus angle A. Okay, so if we want the two angles, we already calculated angle A. Sorry, we already calculated angle A on the previous page. We know that that was sine inverse of 3/5. Which is, I think it was 37, 36.9, so we'll say 37. Okay, so that means that angle A prime would be 180 degrees minus 37, which is 143 degrees. Okay, so one thing I want you to notice here, I have to kind of intelligently figure out what that second angle is. If the angle's not in the first quadrant, you're going to have to do it. You can't just plug in, well, I know the sine ratio for the second angle is also 3/5. If you did sine inverse 3/5 again, well, of course you're going to get 37 again, but that doesn't give you the second angle. So you actually have to know where that second angle is, how it relates back to the quadrant 1 angle, and then do the necessary math, in this case 180 minus the original angle. Okay, so, and that's going to be different for cosine and tan, so we're going to do an example for those guys as well. Okay, so determine another angle between 0 and 360 that has the same cosine as angle A in example 1. So what was that? Let's go back to the first page. So it told us that cosine A is 4/5. So I'm going to write that down. And just like the sine sine ratio that we had for angle A. That gave us two possible angles. This will also give us two possible angles. Okay, so let's see how that works. So in this case, I won't do all the steps we did before, but I know that's x over r. So I know x is positive 4, and I know r is positive 5. And I know that because the r value always is positive. So that means if the ratio is positive 4/5, that means x has to be positive 4. However, when I do my calculation for y, and again, this would be through the r squared, we already sort of did this. If we did r squared equals x squared plus y squared, we would get that there's two possible values for y this time, plus and minus 3. Okay, so if I do a sketch of this, okay, so if I did the positive 3, well, we've already done that picture, right? That's the angle in the first quadrant that looks like this. So that was my original angle A. Okay, so that's this sketch is using y being positive 3, and I can tell that because the y coordinate of this arm goes up to positive 3 for y. What if I change it to negative 3? So I'll put negative 3 down here. That means now the arm comes from the origin down to here. And you can see the symmetry again, very symmetrical. So if that's my angle A, the other angle that satisfies this would be starting at the initial arm, going all the way around counterclockwise till you get to here. So I'm going to call that A prime, just like before. Okay, now we already know that angle A, the original angle A, is 37. We've done that twice already. So that was the, I could do it using cosine inverse of 4/5 as well, get that. Now how do we get angle A prime? Well, angle A prime, let's look at the relationship. If I added these two together, I would get 360, right? So if I want to just have a little formula for how do I get A prime, it's going to be 360, start at 360 and subtract whatever angle A was. So you can see this is a different formula than we had for the sine second angle. I never memorize these. I just kind of look at what it looks like on a sketch and do the logical math from that. I don't like to memorize 3 different formulas for the second angle. Okay, so in this case it's 360 minus 37, which is 323 degrees. So, and you could you could try this out as well. You can test this by saying, okay, let's see if that works. Cos of 323 degrees will be approximately 0.8 or 4/5. It's going to be a little bit off, and the reason why it's a little bit off is because we rounded our original angle A. Remember, it was 36.9 something something something. So you won't get, if you did your check, you won't get exactly the original ratio value, but it will be very close. So that is one way of checking. Okay, and then the last part, probably see where this is going, is working with the tan ratio. So, so we were given the original tan ratio was tan of A equals 3/4. Okay, and we also knew from that ratio that R is equal to 5. Okay, now this is the tricky one because for sine and cosine, we're always able to determine the value of x or y because we always knew that R was positive. So if we had a positive ratio, we knew that x or y was positive. If we had a negative ratio, we knew x or y was negative. In this case, we don't have an r in the tangent ratio. It's y over x. So this could be true, you know, if y was positive 3, x was positive 4, that would work. But also if y was negative 3 and x was negative 4, that would also change to 3/4. So this is where the dilemma comes. So tan A could be, and we already worked with the positive 3 and positive 4 when we started example 1. So the other case that works will be if x and y are both negative. So if y was negative 3 and x was negative 4, that would also give us the same tan ratio of 3/4. So let's write out the values we have there. So this tells us that y is negative 3, x is negative 4, and old trusty r is still positive 5. It never changes. So let's put a box around here. Okay, so what does this look like on a sketch? So again, the first angle A will be the one that we've been drawing for every example, and that's when we had x was 4, positive 4, y was positive 3, angle A is here, and r was 5. Okay, now if we switch up the x and y values to become negative, well, all of a sudden we got negative 3 down here for y, and we have negative 4 here for x. So that will create this angle here, and I'm going to drop my triangle line from the x-axis all the time. So here's my second triangle. So my second angle would be going all the way around here. So this would be angle A prime. And you can see this is the nice one because the second tan angle for the tan ratio is always a difference of 180 degrees. It's directly across the grid, so we always just add 180 to get the second one. So angle A prime will be, well, let's just do the formula, would be angle A plus 180 degrees. So that's 37 plus 180, which is 217 degrees. So angle A prime. So these would be the two angles that satisfy the tan of that angle being 3/4. Actually has two solutions. A could be 37 or A could be 217. Okay, so hopefully those examples that we did kind of show the relationship, looking at the XY grid and a certain sine, cosine, or tan ratio, and the fact that you always have two possible answers for that ratio, two possible angles that satisfy that ratio. And we looked at all three cases on how to determine the second angle that works. The first angle is pretty easy to do. You could just use your inverse function, but the second angle is a little bit trickier. Okay, so I know it can be, this section is a little difficult to understand at first, but hopefully you see the relationship. And like I said on the very first question, if I go back to that, the things that you might be asked to do, and you will be asked to do on your homework, is given a certain ratio, sine, cos, or tan of an angle equals a fraction. First of all, come up with the other ratios that are possible. You know, there's always three ratios. So if I give you one, you should be able to give me the other two if I tell you which quadrant that angle lies in, okay? If I don't tell you, then there's two possible angles that can result. So if the angle's in quadrant one, it's pretty straightforward. But if it's in quadrant 2, 3, or 4, which we haven't done yet, it's a little bit trickier. So The other thing that you can be asked is, what is the measure of the angle or angles? So in this case, when they tell you which quadrant it's in, it's only one answer that it could be. Obviously, it has to be in quadrant 1. But if they don't tell you which quadrant, you could be asked to find the 2 possible angles, which is what we did for in example 2. Okay, we're going to wrap this up with coterminal angles. This is pretty straightforward. So if you think about coterminal angles, okay, you've got your angle in standard position. So say I have an angle of 30 degrees. So there's my terminal arm, there's my angle. Okay, I can drop a perpendicular down if I want. Now, so this question says find 3 other positive angles that have the same terminal arm. So basically the initial arm and the terminal arm aren't changing. So how could you come up with other angles? Well, the answer is just keep going around and around. So instead of just stopping the first time I get here, if I just kept going around, so that angle would be 30 degrees plus a whole rotation. So go all the way back. So 30 plus 360 is 390. If I go around another time, there's another 360. So just keep adding multiples of 360. So that would be 750 degrees. Go around a third time. I guess I'm not really showing all my rotations here, but go around a third time, add another 360. So that's 1,110 degrees. Okay, now how does it work for negative angles? Well, when I was doing my positive angles, I was going in the direction I'm supposed to, and that's counterclockwise. But I could instead, if I have my 30-degree angle here, terminal arm there, so I would go backwards clockwise 360 degrees. Okay, so when I go clockwise, I'm actually subtracting because I'm going in the opposite direction. So the angle that I create if I went clockwise one complete circle would be 30 degrees minus 360. So that would be negative 330 degrees. And again, we just keep subtracting. If I want some more negative angles, keep subtracting 360. So the next one would be 690. Subtract another 360, I'd get to negative 1050 degrees. Okay, so it's really easy. So the formula would be, so coterminal angles. So it's going to be your original angle, and then plus or minus any number of multiples of 360 degrees. So if you want to get some negative angles, you subtract multiples of 360. If you want to get more positive angles, you would add multiples of 360. So it's pretty straightforward. I hope that makes sense. And got some homework questions for you to try out. Hopefully the examples we did is good enough for you to be able to understand that. Okay, so the next lesson we're going to do will be in the we call it reciprocal trig ratios, which is 3 brand new ratios, but don't be too alarmed. They're not going to be brand new. They're going to be just variations of the ones we know and love: sine, cos, and tan. Okay, so thanks for listening, and we'll see you in the next lesson. Take care.